All right, welcome and thanks for joining. Got some pretty interesting, pretty cool questions ahead of our way. So we'll get started right away. 3 times 2 to the x is equal to 96. So the first thing is I want to get this exponential piece of this alone. The operation in between the 3 and the 2 is multiplication. So I'm going to divide by 3 first. I get 2 to the power of x is equal to 32. Now you've got one of two choices. You could either use the inverse property or the one-to-one property. It does not matter which one you do. I'm going to use the one-to-one property, where I say 2 to the power of x is equal to 2 to the power of something. And the only reason I'm using that is because 32 is the same as 2 to the 5th. So now using the one-to-one property, x is equal to 5. Log base 5 of 2x minus log base 5 of 4. I'm going to add that log base 5 of 4 to both sides. So I get log base 5 of 2x equals log base 5 of 4. When I have two bases that are the same of two logarithms that are equal, then the argument of them must be equal. So 2x is equal to 4. Solving that then, dividing by 2, x equals 2. So, not too tough of examples. Moving on a little bit, make them slightly more difficult possibly. Subtract that 16 from both sides. So I get negative 4 times 3x, negative 4 times 3 to the power of x equals negative 16. Divide by the negative 4 so that you can get this 3 to the power of x alone. And then in order to get rid of an exponential function, because like if I'm thinking 3 to what power gives me 4, I have no idea. But what I can do is introduce log base 3 on both sides, so that here it cancels and I'm left with x. Here I get log base 3 of 4, which I still can't really think through, but this is something now that I can put into my calculator. Remember that this would be log 4 over log 3, and that's going to give me approximately 1.262. So now I have an approximation, and then again here I have my exact answer. 3 minus log base 4 of negative 2x. So if I subtract my 3, I get negative log base 4 of negative 2x is equal to negative 3. So log base 4 of negative 2x is equal to positive 3. I just divided by the negative 1 or multiplied by the negative 1, however you want to think about that. When you do that, it's not going to change the argument of this. This is all one term. You're just changing the coefficient sign. Now I want to get rid of log base 4. So I take that base and I say that's going to be the base of an exponential function. That will get rid of my logarithmic function, so I'm left with negative 2x equals 4 cubed. 4 cubed is 4 times 4 times 4, which is going to give me positive 64. And divide by the negative 2. X equals negative 32. So just a little bit more work in those ones. And then moving forward, we're going to end with two questions that have a sort of a lot of work, but some interesting stuff with them. So the natural log of x plus 1 minus the natural log of x minus 2 is equal to the natural log of x. So the first thing I want to do is get this so that it's just one single logarithmic expression. Remember that subtraction between two logarithms can be rewritten using division. So this will become the natural log of x plus 1 over x minus 2 equals the natural log of x. In that case, what I can now do is take e to the power on both sides, because natural log is log base e. So if I do e to that power, it will cancel. Conveniently, it will cancel on the right as well. So now I'm just left with the equation x plus 1 over x minus 2 equals x. And that's all I have to be solving at this point. I'm going to multiply by x minus 2 now. That cancels. I'm left with x plus 1 equals x squared minus 2x. I'm going to bring these over. So I get x squared minus 3x minus 1 equals 0. X squared minus 3x minus 1 equals 0. You know that there are two solutions to this. So it's not factorable, which means I'm going to have to complete the square. That gives me x squared minus 3x plus 9/4 minus 1 minus 9/4, don't need a parentheses there, equals 0. Bring this back up. X minus 3/2 squared minus 13/4 equals 0. Negative 1 is negative 4/4, and another negative 9/4 gives me negative 13/4. At this point, I've now completed the square. What I have to do is solve. So I add the 13/4. I get x minus 3/2 squared equals 13/4. I square root both sides. So x minus 3/2, I don't really need the parentheses anymore, equals plus or minus square root 13 over 2. You don't know what square root 13 is, but you do know what square root 4 is, so you should simplify that. And then add the 3/2. X equals 3/2 plus square root 13 over 2. X equals 3/2 minus square root 13 over 2. If we wanted these as approximations, this is approximately 3.3. This is approximately negative 0.3. And what happens then is we have an issue with this second one. This we would have to reject. And the reason that we reject that is if you go back to the original problem, and if I were to put negative 0.3 into this, it's not within the domain, because I cannot take the log or the natural log of something negative. So like it does work here. If I put negative 0.3 in here, I would add 1 first. So this would be the natural log of something positive. Here it would be negative, here it would be negative, so we reject that. Our only real answer then is this one. And if you just think about that, 3.3, when I put it in here, it's still positive. When I put it in here, it's positive. When I put it in here, it's positive, so it works. So we have to be still paying attention to the domain, even on a question that didn't ask for a domain. All right, we're going to do another example sort of like that. So log of 4x minus log of 12 plus square root x equals 2. I'll rewrite this using division. So log of 4x over 12 plus square root x equals 2. So in this case, I want to get rid of log. The base on log is 10 when it's not written. So I'm going to do 10 to the power on both sides. That gives me 4x over 12 plus square root x equals 10 squared, which is 100. Multiply by 12 plus square root x. So I get 4x equals 1200 plus 100 square root x. And I'm going to move things over to the left in this case so that I can keep my highest power positive. So I get 4x minus 100 square root x minus 1200 equals 0. And I'm just going to simplify this a little bit. I'm going to divide out a 4 from all of this. So it becomes 4 times x minus 25 square root x minus 300 equals 0. And if I divide by that 4, it disappears now. If this was not an equation, I could not get rid of that 4, but because it's an equation, I could divide by it and I still get 0. So moving on up here, I have x minus 25 square root x minus 300 equals 0. So it's a sort of cool thing with this problem because it's not something that you're really used to, but I can complete the square here. Even though this isn't squared, the exponents are in the same ratio as what I would need. So if I'm going to complete the square on this, I get x minus 25 square root x. And then you follow the same process. So half of b, so negative 25 over 2 squared, which is going to give me 625 over 4 minus 300 minus 625 over 4 equals 0. Now, when I write this, you want to be thinking about what do we usually do? So usually this is x squared, and we put x. Because this is x, we're going to put square root x. Because you have to be thinking these two things, or this thing, is going to get multiplied by itself to get here, because eventually I'm squaring it. What goes here is always just half of b. So half of 25 is going to be 25 halves. And then equals, well, let's do minus. This is 1200, so this is going to be negative 1825 fourths. So you could tell, like, this is an awesome problem because it's got a lot of super good math, super good fraction work, and we still got this crazy square root going on. I'm going to move that 1825 over 4. So I get square root x minus 25 halves squared equals 1,825 over 4. I'm going to square root both sides. I get square root x minus 25 over 2 is equal to plus or minus, this breaks down to 5 square root 73 over 2. So, just accept that. Add 25 halves, square root x equals 25 halves plus or minus 5 square root 73 over 2. Now, the problem with this is it has not actually got solved for x yet. What it has solved for is the square root of x. So I'm going to square both sides. So I get x equals 25 over 2 plus 5 square root 73 over 2 squared, and x equals 25 over 2 minus 5 square root 73 over 2 squared. At this point, or really at a previous point, we could have realized that there was going to be a problem. So actually, I'll take a small step back. If we went just over here, let's take a little mid break there. We had square root x equals 25 over 2 plus or minus 5 square root 73 over 2. I'm going to rewrite this just using the subtraction. Square root x equals 25 over 2 minus 5 square root 73 over 2. And if I just did that, this 25 over 2 minus 5 square root 73 over 2 would give me square root x equals negative 8.86. So this right here does not make sense because the square root could not give me something negative. This wouldn't be possible. So you'd have to cancel off that answer and say, no, that's actually not possible. However, algebraically, if you forget to do that, both of these answers, if you went to go substitute back in, well, this one will work. This one, I don't believe would work. I think it would not, or it wouldn't. I'll just say that quite frankly. It would not work. But algebraically, you would have done everything correctly to get this, but it still won't work. The reason is that when you're squaring two sides of the equation, so right here, we squared both sides of the equation, you create the opportunity for extraneous solutions. Because you've essentially said, okay, when I square root, I have to get something positive. But when you squared both sides, you allowed the right side to be negative because when you squared it, it would become positive. But it wouldn't work in the original problem because you had to be square rooting. So that's a little bit complex. And my explanation there is definitely not like the clearest it could be. But extraneous solutions are sort of just a weird topic, and they don't come up a lot at all. But they will come up. And the only time that you want to be looking for these extraneous solutions is when you square both sides of an equation. Anytime that you're doing that, you want to be sort of a little bit more thoughtful about those answers that you're getting. All right, get started on some of that book work. See if you have any questions, bring some in. I'm sure you'll probably have some on the extraneous portion.